Hello friends, welcome to my YouTube channel Ik Onkar Coding. In today's session, I discuss insertion sort to sort the elements in an array. Basically, in this technique, array is virtually divided in two parts. First part is sorted list and second part is unsorted list. Then elements are fetched from the unsorted list into the sorted list by performing the comparisons, and we place the element in the sorted list according to the comparisons, and then we swap the elements. So now we discuss the working of the insertion sort. uh, Now, if there are n elements in an array, how many passes required? N minus 1 passes are required to sort the elements. So now we discuss by example. Suppose we have 5 elements in an array, so it means 4 passes are required. 12, 11, 13, 5 and 6, these are the elements in an array. So now we start our first pass. Now in the first pass, first two elements are compared. So 12 and 11 compared. The thing is, the smallest element we place at leftmost position. That's why 12, 11 and 12 are swapped in the first pass. And after completing first pass, this 11 is in the sorted list. Now this element is in the sorted list and these are in unsorted list. These are the unsorted list. These elements are in the unsorted list. So after this, now we start second pass. So in the second pass, now 11 is in the sorted list and rest of the elements are in the unsorted list. Okay. So now 12 and 13 are compared. So here swapping is not required. So after this, 11 and 12 both are in the sorted list and rest of the elements are in the unsorted list. After this, now we start the third pass. Now before starting the third pass, 11 and 12, these are in the sorted list. These are in the sorted list and these are in the unsorted list. Now 13 and 5 are compared. So 13 and 5, 13 is greater than 5, so 5 and 13 are swapped. After this, 5 compared with 12, so 12 and 5 are interchanged. After this, 5 and 11 are compared and numbers are swapped. And after completing third pass, 5, 11 and 12 in the sorted list and 13 and 6 in the unsorted list. The thing is, basically if you analyze this third pass, the thing is 5 compared with all the previous elements. In insertion sort, we compare the key element with all the previous elements, and then according to the comparisons we place 5 at the correct position. After completing third pass, 5 is placed at correct position, and now 5, 11 and 12 in the sorted list and 13 and 6 in the unsorted list. So now we start the fourth pass. Now in the fourth pass, 13 and 6 are compared. At the starting time, 13 and 6 are compared. So 6 is smallest than 13. So it means we have to place the 6 in the left part. So uh, uh, 6 and 13 are interchanged. Okay, and after this comparison after this comparison 6 and 13 are interchanged. After this, now 6 compared with 12. So 12 and 6 are interchanged. Now 6 compared with 11. So 11 and 6 are interchanged. Now we compare 5 and 6. No swapping is required. So after completing fourth pass, the elements is in the correct position. So for 5 elements, 4 passes are required. Now we discuss another example for the insertion sort. In the previous example, I show you how the elements are swapped in the insertion sort. Okay, and now I give overview of the insertion sort by using this example. So we have elements 4, 3, 2, 10, 12, 1, 5 and 6 in an array. So first we compare 3 with 4 because at the starting time first two elements are compared. Now 13 is swapped with 4. So 3 and 4 are swapped. So 3 come to the leftmost position. After that 4 here, then rest of the elements as such. After this 2 compared with all previous elements. So 2 plays at correct position and 3 and 4 are in, stored in this way. And then after completing this third pass, 2, 3, 4 in the sorted list, rest of the elements are in the unsorted list. After this, now 10 compared with all the previous elements. Now compare 10 first 10 compared with 4. No swapping is required. So 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 10 we place at the same position. After this 12 compared with 10. So no swapping is required. So elements are not interchanged or swapped. After this, now 1 compared with 10, 12, 10, 4, 3, 2, 1 compared with all the previous elements. So after uh, comparing, 1 placed to the correct position and rest of the elements as such. After this, now 5 compared with 12. So 5 is smaller than 12. Then 5 compared with 10. 5 also smaller than 10. So 5 compared with 4. So after this no swapping is required. So 5 we place at this position. After this we compare 6 with all the previous elements. So 6 is less than 12 and less than 10 but greater than 5. So 6 plays at this position. Okay, so after this elements are in the sorted list. Now we discuss the program code for insertion sort. So first we include the header file, then standard packages, then main function. Here I represent the number of passes, j represent the index of an array, n represent the number of elements in the array, temp variable used for swapping the elements. A is an array of size 20. So first we enter the number of elements in the array. So using cin object we enter the value in n variable. After this we enter the elements in the array using this for loop. Here this for loop is closed. So this loop is executed how many times? This loop is executed 5 times. After this now we implement the outer for loop for number of passes. So I is equal to 1, 1 less than 5, condition 2, 2 less than 5, 3 less than 5, 4 less than 5, 5 less than 5 condition false. So this loop is executed how many times? This for loop is executed 4 times. It means 4 passes are executed by this for loop. After this I declare a variable j, initialize j with value I, So one value goes to the j variable. Now we compare. Now using this j index, we compare second element that is at one position, at one index. The element placed at one index we compare with zero index. So that's why here I implement a while loop. Why I am implementing the while loop? Because in this we have to compare the key element with all the previous elements. So that's why I here give the condition j greater than 0. And here and operator is required. Two times and is used because I have to combine these two conditions. There is no need to write j greater than equal to 0 because here I am writing a of j minus 1. So equal to 0 is not required because 1 greater than 0 and 1 minus 1 it becomes 0. So equal to 0 is not required, because if you write here equal to 0, this index becomes minus 1 because minus 1 index is not existed. That's why I write here j greater than 0. Then a of j minus 1 means j in at the starting time j has a value 1. 1 greater than 0 condition true. 1 minus 1 means a of 0. A of 0 is greater than a of 1. If 0 index element is greater than first element, it means swapping is required. So in this while loop I perform the swapping. So here I write temp is equal to a of j. A of j is equal to a of j minus 1. A of j minus 1 is equal to temp. Now j is decremented. Why here j is decremented? Because I have to compare the key element with all the previous elements. But in first iteration we have single previous element, so j minus minus becomes 0. And in the while loop I give the condition 0 greater than 0, condition false, because we perform in the first iteration, in the first pass we perform only single comparison. Okay, I hope you understood. After this I is incremented. When I is incremented, now 2 less than 5, condition true. Now j become 2. Now 2 greater than 0, condition true. Now a of 2 minus 1 means 1. A of 1 compared with a of 2. So if a of 1 is greater than a of 2, then elements are swapped. And after this, after performing swap, in the last statement j is decremented. When j is decremented, j becomes 1, and 1 greater than 0, again condition true in that case. So after this a of j minus 1 becomes 0. A of 0 is greater than a of 1. Okay, so in this way, using this while loop, all the previous elements are compared. So after completing this both two loops, elements are in the sorted order. So after this we execute a for loop to display the elements in the output screen. So all elements are displayed separated by tab space. So I hope all of you understood the code of the insertion sort. So now we discuss the time complexity of the insertion sort. The thing is, the worst case time complexity is big O of n square, because two for loops are implemented, one for loop and one while loop is implemented. So the complexity becomes big O of n square, and average case complexity is again big O of n square, and best case complexity is big O of n. So now we discuss how the best case complexity is big O of n. The thing is, best cases happen when all elements are in the sorted list. So suppose we have these elements 1 2 3 4 5. Okay, so in the first pass we discuss how many comparisons we performed and how many swapping we performed. So in the first pass, 2 compared with 1, 2 compared with 1 comparison. And how many swaps? 0 swap, because swapping is not required na. So after this 3 compared with 2 in the second pass, 3 compared with 2, so how many comparison? Oh, again 1 comparison. And how many swaps? 0 swap. After this 4 compared with 3, again 1 comparison and 0 swap. After this 5 compared with 4 and 5 are compared, so 1 comparison, 0 swapped. So how many comparisons we performed? If there are n elements, n minus 1 comparisons are performed. So using this, what complexity become? The complexity becomes big O of n. Okay, because number of swaps are 0 in the best case. That's why the complexity becomes big O of n. In a similar way, if you discuss about the worst case complexity, in the worst case complexity, how many comparisons we performed here? Only one comparison we performed. And in the worst case, if elements are in the unsorted list, so here elements are 5 4 3 2 1. So in the first iteration, one comparison we performed. In the second pass, 3 compared with 4 and 5 both. Okay, or you can write here 4 here in the first pass. After completing first pass, 4 5 3 2 1, these elements are become 4 5 3 2 1. So 3 compared with all previous elements. So here the comparisons becomes 2, here comparison become 3, here comparison become 4. So series is formed 1 plus 2 plus 3 up to n minus 1. So the complexity becomes, and the formula is n into n minus 1 divided by 2, and the complexity becomes big of n square. So I hope all of you understood the time complexity. So thank you all for watching my video, and if you like the video, then like my video and subscribe my channel and share my video with your classmates. Thank you all.